Okay, fine. So let's yeah, good afternoon once again. So today we are going to see the previous year's questions of haloalkanes and haloarenes. Okay. So some of the JEE and NEET questions I have taken for you guys, and today we will try to solve those. And I hope all the concepts that we have learned under this haloalkanes and haloarenes lesson are clear, and I hope you guys have revised those lessons. Okay. So let's go ahead with the first question from this lesson. So here is a question. The given compound is an example of. The given compound is an example of aryl halide, allylic halide, vinylic halide, and benzylic halide. So which is the correct answer for this? So this is a question from the classification, nomenclature, and the nature of CX bond topic. Mainly it is under the classification of the compounds. So can you able to find out the answer for this? So tell me which option is correct.
Option D.
Students, did you get the answer for this question? Which option is correct? Option A, B, C, D. So Vedant is saying option D is the correct answer. What about Madhukar? What about Madhukar? You are also going for D. Option B is the correct answer. So you see, it is an allylic halide because the halogen is attached to the carbon which is having only single bond. So it is an sp3 hybridized carbon. Okay. And it is attached to an sp2 hybridized carbon, and that also attached with another sp2 hybridized carbon. So we have carbon, double bond carbon, single bond carbon, and it is attached to halogen. So I told you, right? Double bond, and single bond. So this kind of pattern is an example for allylic system. Got it? So just because we have the benzene ring or phenyl ring in the compound, we cannot go for option D. It is not benzylic halide. Benzylic halide means we will have this ring and it will be attached to CH2 and directly we will have X. Okay. We have double bond, and single bond, right? So this is called as the benzyl group. So we don't have any such groups here. So it is an example for allylic system. Clear for clear? So shall we go for the next question, students? Can you all able to understand this? Yes? Okay. So the next question is, identify the correct of reagents or reaction conditions X and Y in the following set of transformation. So can you able to find out X and Y? So we have an alkyl reactant side, and on treatment with X, it is produced. And that product is treated with Y to give the 2-bromo-propane. Okay. So which one can be X and which one can be Y? Which one is X and which one is Y? Can you try? Did you get the answer, students? Very good, Vedant. Option D. Correct answer. Your answer is correct. So here what happens when alkyl halide is treated with X, I mean X is concentrated alcoholic KOH, right? So alcoholic KOH. Alcoholic KOH is doing elimination. So it is an elimination reaction. So when CH3, CH2, CH2, Br is treated with concentrated or alcoholic KOH, so the beta hydrogen will be eliminated. So this is the alpha carbon and this is the beta carbon. So we have 2 beta hydrogens. So one of the beta hydrogen will be attacked by the OH minus. Okay, OH minus will go and attack the beta hydrogen and the bond will shift here. The carbon halogen bond will break. So we will get CH3, CH double bond CH2. Okay, this is the product. And if this is treated with the reagent Y, Y means it is HBr. HBr in presence of acetic acid is CH3COH. Acetic acid is a solvent, okay? So it will not take part in the HBr will react. So addition of HBr to alkene is an example for Markovnikov's addition. It is an example for Markovnikov's addition. So according to Markovnikov addition, what we have to do? We have to break the double bond, add bromine to the carbon which has less number of hydrogen, and add hydrogen to the carbon which has more number of hydrogen. So this carbon is having 2 hydrogen and this is having only 1. So the negative part, that is Br minus, will go to the carbon which has less number of hydrogen. So from this we will get CH3, CH, Br, CH3, and this is given in the final product, right? So X is alcoholic KOH and Y is HBr. Clear for all of you? Any doubt? Clear for all of you? Shall I go for the next question? Shall I go for the next question? Yes. So question number 3. The major product formed in the dehydrohalogenation reaction of 2-bromopentane is pent-2-ene. This product formation is based on Huckel's rule, Zaitsev rule, Hunt's rule, Hoffman rule. Which is the correct answer? This is the correct answer. This is also the elimination reaction only. So we have pentane 1, 2, 3, 4, 5, and to the second carbon we have to attach the bromine. Okay, so 3 CHBr, CH2, CH2, CH3. Dehydrohalogenation. Dehydrohalogenation means elimination. Elimination is done with alcoholic KOH or alcoholic NaOH. Okay. So what will be eliminated? HBr will be eliminated and we will get a double bond here. So we will have CH3, CH, double bond, CH, CH2 and CH3. So what is this? 1, 2, 3, 4, 5. So it is called as pent-2-ene. Between carbon 2 and 3, we have a double bond, right? So it is pent-2-ene. So why pent-2-ene is formed as a major product? One more product is also possible. You know what is that? So I can, carbon is also the beta carbon. So if I eliminate this HBr, I will get the double bond here. So I will get CH2, double bond CH, CH2, CH2, CH3. Okay. So what is pent, pent 1-ene. This compound is called as pent 1-ene. Okay, very good, very good. Very good, Madhukar. So it is pent 1-ene. So we get two product. But first one is the major and the second one is the minor. And the more substituted alkene will be the major product. Pent-2-ene is more substituted because if you see we have the methyl group attached to the double bonded carbon and here we have an ethyl group attached to the double bonded carbon. But here we have only one group, propyl group attached to the double bonded carbon. Rest, other three are hydrogen. So the more substituted alkene will be the major product and this is disubstituted and this is monosubstituted. Okay, so this rule, more substituted, the major product is the Zaitsev rule. So option B is the correct answer. Almost all of you have given the correct answer here. Option B is the correct answer. Okay, so what does this rule says? What is Zaitsev rule? What is Zaitsev rule? More substituted alkene is the major product. Okay, so please write down more substituted alkene will be the major product. Got it? So I'll go for the next question. I hope this question is clear to all of you. We'll go for the next. Which of the following alkane cannot be made in good yield by Wood's reaction? Which of the following alkane cannot be made in good yield by Wood's reaction? Can you find out the answer? Which of the alkane I am please find out the answers. Alkane cannot be made in good yield. Option A. Bishan is also going for option A and Madhukar Reddy is also going for option 1. Okay. So do you remember one point which I have said? Vedant and Rowing is going for option B. Okay. So I'll ask one question to Vedant and Jane Rowing. Why you guys have gone for option B? What is the reason, Vedant and JNV rowing students? Why you guys have gone for option B as the correct answer? We go for Vedant and JNV rowing first, and then I will come to Madhukar and Bishan. Students, tell me what is why option B is the correct answer, Vedant? Very good. Very good. So I told when I'm teaching the Woods reaction, I told that only symmetrical alkanes can be prepared using Woods reaction, right? Symmetrical alkane means the even number of carbon containing alkane. Even number of carbon containing alkane. Okay. So here if you see, in the option A, we have 2,3-dimethylbutane. So this is butane, and to the second carbon and to the third carbon, we have a methyl group, CH3. So if I cut this molecule, I will get two here. So it is a symmetrical alkane. So this particular alkane can be prepared using Woods reaction. Okay. But when I go for N-heptane, 7 carbon, right? 7 carbon. 7 is the odd number. 7 is the odd number. So it cannot be prepared in a good yield. So it is unsymmetrical. It is unsymmetrical, so it cannot be prepared. Got it? So option C and D we can prepare because in option C we have butane, which is a even number of carbon containing system, so it can be prepared. And hexane means there are 6 carbons. So it also has even number of carbon and it is symmetrical with respect to this bond. So it is also prepared using the Woods reaction. So the only alkane which cannot be prepared is option B. So option B is the correct answer. So is it clear for Madhukar and Bishan? Did you get the point? Did you guys get the point? Shall we go ahead with the next question? Yes. So coming to the statement type question, assertion and reason. Yeah. Assertion says that SN2 reaction of C6H5CH2Br occurs more readily than the SN2 reaction of CH3CH2Br. So first, please analyze the assertion and tell me whether the assertion is correct or not. So assertion A correct or it is wrong. Assertion is correct or it is incorrect, students? C6H5CH2 means C6H5. This component is C6H5 and this is CH2 and this is Br. Okay. And the other compound is CH3CH2Br. And what is meant by SN2 reaction? Substitution nucleophilic bimolecular. Okay, so the Br nucleophile will be substituted by some other nucleophile. So what they are asking, what they are saying, so the first compound, the benzyl bromide, is more readily reactive than the ethyl bromide, the second compound. Is it correct? What is your opinion? What do you guys say? It is correct or it is wrong? It is correct. Okay, it is correct. So it occurs more readily because benzene is a more stable compound and this will be stabilized through resonance, and that is what is given in the reason. You see, the partially bonded unhybridized p orbital that develops in the trigonal bipyramidal transition state is stabilized by conjugation with the phenyl ring. So SN2 means we will get a pentavalent transition state, right? So do you remember in SN2, carbon will form the 5 bond compound. For the first compound, we have the carbon and we have two hydrogens and one bromine. So if some other nucleophile is coming, that will try to form the bond with this carbon. Okay, that nucleophile will try to come and form the bond with this carbon, and this carbon halogen bond will try to break. So this is the pentavalent for this system where the carbon is having, in which the carbon is having 5 bonds. Okay. So in this pentavalent transition state, this particular carbon is getting stabilized through the conjugation with the phenyl ring. So this is the phenyl ring. So this carbon will be stabilized through this conjugation. Okay. The pi electrons which is present on the ring will come and stabilize. If some delocalization or if some conjugation is present in the compound, then that will stabilize the compound. Okay, so such kind of stabilization, the delocalization is not possible in case of CH3, CH2Br. Okay, so if I have CH3, CH2, Br, and if some nucleophile is coming here, and this bond will try to form and this will try to break. Okay, so here I don't have any type of delocalization or conjugation. So the second compound cannot be stabilized. So if something is going to attain the stable state, that will be more stable, more favorable, and it is more readily reactive. Okay, so assertion and reason are correct, and R is the correct explanation of A. So option B is the correct answer. Can you able to understand this question, students? The partially bonded unhybridized p orbital means the benzene ring will have one p orbital. Each carbon will have one p orbital, and that is unhybridized. Okay, so that develops in the trigonal bipyramidal transitions. Why it is called as trigonal bipyramidal? Because we have 5 atoms. So this is trigonal, and if I connect this and that, I will get bipyramid. Okay, so that particular pentavalent transition state is stabilized by conjugation. Conjugation means the delocalization with the phenyl ring. Got it? Clear for all of you? Is this question clear for all of you? Students, are you here? Am I audible? Students, shall I go for the next question? Yes? Okay. So coming to the next question, again an assertion reason type question. So assertion says, haloalkanes react with KCN to form alkyl cyanide as a major product. Haloalkane. What is meant by haloalkane? RX. Okay. It reacts with KCN to form alkyl cyanide as the major product. While with AgCN, when RX is treated with AgCN, it forms isocyanide. Isocyanide means RNC. Okay, as a major product. And this assertion is correct. With KCN, it forms cyanide, and with AgCN, it forms isocyanide. Okay. It is because KCN is an ionic compound. It is classified into K plus and Cn minus. So it is an ionic compound. Okay, so for ionic species, cyanide will be the major product. But AgCN is a covalent compound. AgCN is a covalent compound. So silver is here, and this is a covalent bond, and it is triply bonded with the nitrogen. So only nitrogen is available. Nitrogen center is available, and nitrogen will go and form the bond with this R group. So we are getting a nitrogen R bond in the product side, and we call this product as isocyanide. Okay. But for ionic species, we have K plus and Cn minus, right? K plus and Cn minus. So both nitrogen center and carbon centers are available. So they can form cyanide as well as isocyanide, but cyanide will be more favorable. That will form as a major product. But here cyanide formation is not possible at all, since carbon is not available to form the bond with the R group. Okay, so assertion is correct. When you come to the reason, they are saying that KCN and AgCN both are highly ionic. No, that is wrong, right? KCN is alone ionic. AgCN is covalent in nature. So, which is the correct answer for this question? A is correct. R is not correct. Answer. Clear? Is it clear for all of you? Able to understand? Can you able to understand this? Shall we go for the next? Shall we go for the next? So if you do not know this concept before, please write this concept in your notebook. Ionic compounds will form cyanide and covalent compounds will form isocyanide. So you know why I have said the potassium forms ionic compound and silver is forming covalent compound. Potassium, this K, is an S block element and the silver is a D block element. So the elements which are present in the left side of the periodic table mostly will form ionic compounds and the D block and the P block will form ionic compounds. Got it? The elements which are present at the middle of the periodic table mostly they will form covalent compound. So that's why it is classified into ionic and covalent like this. All right. Shall we go for the next? Do you have any doubts in this question? Do you have any doubts in this question, students? Okay. So what about others? Only Vedant is replying. Bishan, Madhukar, Jainvi rowing. Is it clear? Okay. So coming to the next. The product C in the below mentioned reaction is. Okay. So find out the product. Find out the product C. So we have the reactant, bromopropane is the reactant. It is treated with alcoholic KOH, then with HBr, then with aqueous KOH. So what will be the product A? Can anyone give me product A formula in the chat box? Vedant is going for option C. Okay, what about others? What about others? So what is compound A? We have CH3, CH2, CH2 and Br, right? It is treated with alcoholic KOH. So Bishan is going for option A. So let's see which option is correct. Alcoholic KOH. So just now I said alcoholic KOH means elimination reaction. So what will be eliminated? This H and beta hydrogen and the bromine will get eliminated. We will get a double bond, right? So it will be CH3, CH, double bond, CH2. This is compound A. And this compound is treated with HBr. So what is this? This is Markovnikov's addition. This is Markovnikov's addition. Okay. Markovnikov's addition. So you have to break the bond and add Br and H here. So we will get CH3, CH, Br and CH2, CH3. Okay, this is compound B. Then what happens? We are heating this compound but in presence of aqueous KOH, right? Aqueous. Alcoholic KOH will lead to elimination. Okay. Alcoholic KOH will lead to the elimination product. Aqueous KOH will lead to the substituted product. So what will happen here? Substitution will occur for aqueous KOH. So we have K plus and OH minus. OH minus is the nucleophile. So the Br nucleophile will be substituted by OH nucleophile. So we will get CH3, CH, OH and CH3. Okay. So this is the final product C. Now, what is the IUPAC name of this product? We have three carbons, 1, 2, and 3. To the second carbon, we have an alcohol group. So, it is propan, propan, 2 all. Okay. It is propan, 2 all. So, option C is the correct answer for this question. So, is it clear? So, please write down in your notebook that alcoholic KOH will lead to the eliminated cis product and aqueous KOH will lead to the substituted product. All right. Bishan, can you able to understand why option C is the correct answer and why not A? We have to do Markovnikov addition, right? Markovnikov means the negative part will go to the carbon which has less number of hydrogen. Got it? Yes. Shall we go for the next question, students? Shall we go for the next question? Okay. Assertion. So we have a compound and they are saying it is an example of allyl halide. And the reason says that allyl halides are the compounds in which the halogen atom is attached to sp2 hybridized carbon atom. So find out the correct answer for this question. I have told you what is an allylic system in the beginning of the session, right? So find out the answer first. So Vedant is saying it is option A. What about others? What about others? What about others? Did others get the correct answer? Students? Option A. Okay. Fine. So let's go ahead. Okay, let's go ahead. So assertion says that it is an example for allyl halide. That is the correct assertion. That is the correct assertion. You know why? So we have double bond, carbon-carbon double bond, single bond and single bond with halogen. So this is an example for allylic system. So it is correct. And the halogen attached to carbon, this carbon, okay, halogen attached to carbon is having only single bonds, right? Single bonds means it is sp3 hybridized, okay? Halogen atom is attached to sp3 hybridized carbon and not sp2. So assertion is true, but reason is false. So that's why option A, which you guys have told, is the exactly correct answer. Okay. Very good. So I'll go for the next question. Which among the following is an example for vinylic halide? Allylic means we should have three carbons in double bond, single bond manner. What about for vinylic halide? Can you guess the answer? This one also we have studied under classification only, right? Can you find out the answer? What is vinylic system? So you guys are going for option C. No, option C is not correct. So the correct answer lies in option A, B, and D. So find out the answer. I will give you one more chance. C is not the correct answer. C is an example for aryl halide. Aryl, haloarene, aryl halide, okay? Option B, no, it is also not correct. So let me go ahead. Listen. Allylic means 3 carbon, vinylic means 2 carbon. Vinylic means it should be 2. Madhukar, your answer is exactly correct. Option D is the correct answer. Vinylic means we should have carbon-carbon double bond, and that carbon will be directly attached to the halogen. Okay, so this is the vinylic system. So can you able to understand the difference between allyl and vinyl? Allyl means carbon-carbon double bond, single bond, and then X. So this is allyl. Okay, and carbon-carbon double bond with X means it is vinyl. So now you check which option is having this. So here in option A, we have carbon-carbon double bond and carbon-carbon single bond. So this will go in allyl, so it is not the answer. And when you come here, we have carbon-carbon double bond and carbon-carbon single bond, and then that is attached with halogen. So this is also allyl, okay, where 3 carbon is involved. So it is also not the answer. When you go for option C, it is an haloarene, or I can say it is an aryl halide. Okay, so the benzene is having attached directly to the halogen atom. So it is an aryl halide. It is an aryl halide. So it is also not the example. And when you come to option D, we have carbon-carbon double bond, and that is directly attached to the halogen, and inside this ring we don't have any delocalization possible. Okay, so this is an example for vinylic halide. So option D is the correct answer. If the halogen is directly attached to the phenyl ring where it has 3 pi bonds inside it, so that is an example for aryl halide and not the vinyl halide. Okay, you should not just see this part alone. You have to look into the entire compound. Okay, if the compound has pi bonds inside it, then that will not be the answer for vinylic system. Are you getting my point? Students, did you get the answer? Did you get why option C is incorrect? Yes. Good, good. So now we will go for the next question. Assertion reason type again. Assertion is saying that aryl halides cannot be prepared by the replacement of hydroxyl group of phenol by halogen atom. Is that correct? Aryl halides cannot be, aryl halide means haloarene, okay? Haloarene cannot be prepared by replacement of hydroxyl group. Hydroxyl means OH group of phenol. You all know what is phenol, right? C6H5, C6H5OH is called as phenol by halogen atom. Replacement of hydroxyl group of phenol by halogen atom. Is that correct? Can we prepare the haloarene from phenol? Haloarene means C6H5. For example, let me take Cl, okay? So this is aryl halide. Aryl halide cannot be prepared by the replacement of OH group of this phenol by the halogen atom. They are saying this reaction will not occur. So what is your answer? Is it true or false? Can we replace OH by Cl directly? Can we replace the OH by Cl? No, it is actually answer is assertion is true. Assertion is true only. Very good. But the direct substitution of OH by Cl is not possible and the reaction will not occur. Okay. So the statement which is given in the assertion is correct only. So what is the reason they are trying to say? Phenols react with halogen acids violently. What about this statement? Is it true or false? Assertion is true. What about the reason? Phenols react with halogen acids violently. Is it true? Madhukar is going for option A. Okay, let's check, Madhukar. So phenol is here. Phenol reacts with halogen acid. Halogen acid means HF, HCl, HBr and HI. So let me write it in a general format, which is HX. Okay, so do you think phenol will react with the HCl, HBr directly and violently? No. No, the answer is no. So no reaction will happen. Phenol will not react with halogen acid in a violent manner. So assertion is correct, but reason is false. Option A is the correct answer for this question. Okay. Shall we go for the next? Shall we go for the next? Okay. So coming to the next question, which among the following halide will not show SN1 reaction? Which of the following will not show SN1 reaction? SN1 reaction means the reaction will happen in two-step, right? SN1 is a two-step reaction. So in step 1, what will happen? There will be the formation of carbocation. Okay. And in step 2, what will happen? In step 2, nucleophile will come and attack. Attack of nucleophile. Okay, these are the two steps that occurs in SN1 reaction. Now, from this, find out the answer for this question. Check whether all the given 4 compounds will undergo step 1 or not. What about the first compound, compound A? What about compound A? Compound A will show SN1 or it will not show SN1? Will there be the formation of carbocation? So straight away, Madhukar is going for option. Option C. Yes. Option C is the correct answer. But why option C is the correct answer? So in compound A, if you see, we have the halogen attached with sp3 hybridized carbon. So if this halogen goes out, we will get the carbocation here. We will get the carbocation. So that carbocation is more stable because it is stabilized by resonance. Okay. So SN1 will occur. In case of option B, the halogen is attached with the double bonded carbon. So the hybridization is sp2. If the hybridization is sp2 and if the carbocation is on the sp2 hybridized carbon, then that makes the system highly unstable. Okay. What will be the formula? CH3 CH double bond CH plus. So this kind of carbocation we will get. Okay. So if the nucleophile, if the Cl leaves the compound, we will get this type of compound, carbocation. And this is highly unstable. Why it is highly unstable? The positive charge is located on the sp2 hybridized carbon. So this makes the system highly unstable. So SN1 cannot be shown by this compound. Okay. So second compound will not show SN1. When you go for third compound, halogen is attached with sp3 hybridized carbon because it has only single bond. So even after the leaving of Cl, we will get a carbocation and that is benzyl carbocation and it is stabilized through resonance. It is stabilized through resonance. So SN1 will occur. When you come to option D, I mean the compound D, we get a carbocation here and this carbon is also having only single bond around it, which is an sp3 hybridized carbon. So SN1 will occur in compound D also. So compound B is the only compound which will not show SN1 because of this reason. Is it clear for all of you? Shall we go for the next? Shall we go for the next question? Shall we go for the next question, students? Or no? Am I audible? Okay. The correct statement regarding substitution reaction in a chiral alkyl halide is. What is meant by chiral alkyl halide? The carbon which is attached to 4 different groups is called as chiral alkyl halide. Okay, so I have a carbon and let me take the halogen as Cl and let me take this as hydrogen and what is this? What I can take this? So this is some compound or atom X and this is atom Y. Okay, this is a chiral alkyl halide. So if this chiral alkyl halide undergoes nucleophilic substitution reaction, which among the following is correct? They have given the SN1, SN2 reaction in terms of the configuration. Okay, in terms of configuration. So we have studied two types of reaction, SN1 and SN2. SN1, racemization occurs in racemization occurs and in SN2, inversion occurs, right? So that is what we have studied, no? In SN1, we get a 50-50 mixture, right? Racemic mixture we will get. So that is called as racemization, where we get the both inverted product and the retention product. But in case of SN2, 100% inverted product only we will get. And also I told that inversion is called as umbrella inversion, right? So the 100% inverted product we will get in SN2, but 50-50 mixture we will get in SN1. So which is the correct answer? Option D. Racemization occurs in SN1 and inversion of configuration occurs in SN2. So do you guys remember this configuration point which I have quoted when I am teaching the SN1 and SN2? Can you able to recall? Can you able to recall that point? Yes. If you have revised this lesson, this will be very easy. You can easily get the answers. So I will go for the next question. Okay. The major product formed in the Friedel-Crafts acylation of chlorobenzene is. The major product formed in the Friedel-Crafts acylation of chlorobenzene. Yesterday only we have seen this, no? Under electrophilic substitution reaction, I have taught. So we have the chlorobenzene. We have chlorobenzene. And this should undergo Friedel-Crafts acylation. So what is meant by acyl group? CH3, CO, Cl. So this part is called as acyl group. And it should be treated with anhydrous AlCl3, right? So these two are the acylating agent. So from this acylating agent, we will get an electrophile and that electrophile will be CH3CO+, right? So this electrophile will go and get substituted in the ortho position and para position. Yeah, very good, Vedant. So it will go and get substituted in the ortho position and para position. So let me write both the product. So this is the ortho product and this is the major product, which is para. This is the para product. Okay. So yesterday itself I told, right, para product will be the major product. So option A is the major product for this reaction. Clear? So these are the direct questions. These are the direct straightforward questions from the reactions which is given in the book. Got it? So now I'll go ahead with the one question. which is of match the following type. So can you find out the answer? So chlorobenzene is treated with CH3Cl in presence of sodium and it is forming CH3. So what is the name of this reaction? This will come under the reaction with metal because we have sodium metal, right? Reaction with metal. Yesterday we have seen this reaction under the reactions of haloarenes. So this is an example for which reaction? So we have taken haloarene and this is an haloalkane. So if 1 mole of haloarene and if 1 mole of haloalkane is treated, then it is an example for Woods-Fittig reaction, right? It is an example for Woods-Fittig reaction. Then if 2 moles are, if both the molecules are chlorobenzene, if both of them are haloarene, and if it is treated with 2 sodium, actually 2 moles is reacting, okay, that is the meaning. So what will happen? 2 NaCl will go out and both the phenyl ring will connect with each other, okay. So we get a biphenyl. So we have got here, we have got a biphenyl group and this is an example for Fittig reaction. This reaction also I have discussed yesterday. And benzene diazonium chloride with the Cu2Cl2. Benzene diazonium chloride with the Cu2. Yes, Vedant. Yes, Vedant. Option B is the correct answer. Cu2Cl2 means it is an example for Sand-Meyer reaction. Under the preparation of haloarene, we have seen this. Okay, this is an example for Sand-Meyer. And the last reaction is the preparation of iodoalkane using sodium iodide. So iodoalkanes can be prepared using Finkelstein reaction, right? So option B, A2, B1, C4 and D3 is the correct answer. Clear? So this question is very easy question. So they're just asking us to match the reaction with the name. If you have revised it properly, you can get the answer within a fraction of a second. Okay. So let me go ahead with one more question. And this question is the last question for today's session. So find out the answer first. The correct order of melting points of dichlorobenzene is. So this is a question from the physical property. From the physical properties of haloalkanes and haloarenes, I have taken this question. And this is a previous year question also. So find out the answer. Which will have the highest melting point? Option D. No, option D is not the answer. Para dichlorobenzene will have the highest melting point. Okay. I also gave the reason, right? So para compound will have the symmetrical structure and the packing efficiency will be very, very high. So if the packing efficiency is very, very high, it will not get melted so easily. So it will take high temperature to melt. Okay. So because of its symmetrical structure and high packing efficiency, para will have the highest melting point. Okay. Next to para, ortho will come. Then only meta. So option A is the correct answer. Okay. Option A is the correct answer. Clear? So you can see the values in the book. First para, then ortho, then meta. Got it? So this is all for today. And I hope today's session, the problem solving session, is very useful for you guys. Is it so? So did you understand how to apply the concepts that we have studied? Yes? Yeah. So thank you so much for attending the today's session, students. Kindly give your feedback in the poll which I have launched. So in the next class, we will start the new lesson. Okay. So I will start with the alcohols, phenols and ethers in the next session. Got it? So please give your feedback and then get ready for your next class. Thank you so much.